Hello everyone, this is Gary Liu and welcome to my next calculus lesson. Today we are going to be doing one-sided limits. So what are one-sided limits? Well, the limit as x of f of x as x approaches c negative is the value f of x approaches as x approaches c from the left. And the limit of f of x as x approaches c positive is the value of that f of x approaches as x approaches c from the right. So let's go on to our first example. So here we have a piecewise function. If f of x is equal to x plus 5 if x is less than 3, and x plus 4 if x is greater than or equal to 3, then what's the value of limit of f of x from as x approaches 3 negative? So here we have a graphical representation of it. Yeah, I used Desmos.com to graph this. So as you can see, on the left of x is equal to 3, you have the equation of the line x plus 5, and on the right of x is equal to 3, you have the equation of the line x plus 4. So basically what this means is, as x approaches 3 from the left, what value does y approach? And as you can see, as x approaches 3 from the left, y approaches 8, so the answer is 8. How can you calculate that? Basically, since it's approaching 3 from the left, what matters is what's on the left side of 3. So we're going to use x plus 5 because that's on the left side of 3. And directly substitute 3 in, and you should get 8. So next is if f of x is, well, it's the same function as last time, but this time I'm asking, again, what is the limit of f of x as x approaches 3 positive? So here's our graphical representation again, and basically this now it's asking what value does f of x approach if the graph approaches 3 from the right. So this time we're going from the right, not from the left. So as x approaches 3 from the right, y approaches 7. How to calculate? Well, now what matters is what is on the right of 3. So that would be x plus 4, directly substitute 3 in, and you should get 7. Okay, so when does a limit not exist? When x approaches different values from the left and from the right, the limit does not exist. Or in other words, the limit does not exist when the limit of f of x as x approaches c negative is not equal to the limit of f of x as x approaches c positive. So let's go on to our first example of this. Does a limit exist for the following function? If so, what is it? So we have the limit of f of x as x approaches 1, and this is our function for f. So here is our graphical representation of it. And I actually got this picture from this site here. So as you can see, as x approaches 1 from the left, that the y actually approaches 1. As x approaches 1 from the right, y approaches 2. Here, see that? So since it approaches different values from the left and from the right, the limit does not exist. And how can you calculate that? First, let's calculate limit of f of x as x approaches 1 minus. And since it's minus, what matters is what's on the left of 1. So we're going to use x squared because that's on the left of 1, and then substitute the 1 in for x squared, and you should end up with 1. And now let's see what value does it approach from the right. So now what matters is what's on the right of 1, which would be 3 minus x. So we're going to do 3 minus x, and then substitute 1 in for x, and you should end up with 2. And since the limit as it approaches from the left is not the same as it approaches from the right, the limit does not exist. Next question, does the limit exist for a following function? If so, what is it? So as you can see, x plus 1 for the graph is basically, this function is basically the graph of x plus 1, except at the x equals to 1, you can see that it's equal to -1 at x equals to 1. And there's a hole here. So what we're asking is, does the function exist? And yeah, the answer is yes, indeed it exists. Even though there's a hole here. Because remember, we're just asking what value does it approach. I was like, yeah, I said this already. We're asking what does it approach, not what value is it on. So, as you can see, it approaches 2 from the left and it approaches 2 from the right. So the limit does exist and it's 2. How do you calculate? Well, on the left of x is equal to 1, you get the function x plus 1 and substitute that and you get 2. And I'll do the same thing from the right because like on both sides of x equals to 1, you do have the function x plus 1. So either way you get 2, and since it's the same from both sides, the limit does exist. So it is 2. Now does the limit exist for a following function? If so, what is it? So this time we have a different function. 1 equals to 1 over x squared. Here's our graphical representation, which I used mathisfun.com to graph. So yeah, you can see that from both sides, it appears to be approaching infinity from both sides. Like, see, notice that from both sides it's getting infinitely large. So the limit is infinity. If you would like to try to calculate this, then what you can do is calculate, just get some values from get some values close to 0 from both sides and keep making them closer to 0 and see what value it approaches. And see, notice it's getting large really quickly, so the limit must be that approaches infinity. Okay, so put that away. So now let's do 1 over x. So our graphical representation is this. So, but however, like, just notice that from the left it approaches negative infinity, and from the right it approaches positive infinity. So the limit does not exist. How to calculate? Well, you could just do an estimation, plug in values that are close to 0 from both sides, and keep making them closer to 0. And notice that from the left it's approaching negative infinity, and from the right it's approaching positive infinity. Thus, the limit does not exist. Okay, so we have our last example here. The limit as x approaches 0 for the square root of x. Our graphical representation again. And just note, there's nothing on the left of x equal to 0, but still the limit still exists because as x approaches 0, y still approaching 0, so the limit is 0. How calculate that? The limit, just directly substitute 0 in for x and you get square root of 0, that's equal to 0. So, hopefully you enjoyed this lesson on one-sided limits. If you find this helpful, please comment, like, or subscribe for more videos. And I'll see you guys later.